Okay, so guys, it's your show now. We're going to start with this packet. This packet, you only went through 25. Now, the rest of them you need to do before Friday, right? Because the rest of them cover Friday's material on the test. The solutions are already posted. You don't have to do it tonight. No, because the rest of it isn't on tomorrow's version.
Mine is.
Oh, that's right. You have to take both.
And you get to home at 10. I'm trying to tell him, don't quit your job.
I'm ready.
Early, because you're gonna...
If I leave my job early.
Noah, what is your question?
Okay. Same question, so I'm getting a good question. For number 12.
Number 12.
It says for the.
Oh, yeah, these are bad directions. You can't compare log base 3 to ln.
I was thinking it was like 3 over x.
No, that was just a goofy on my part. You would only compare this with y equals log base 3 of x. So that was just me overlooking that in the directions. These really only tell you what to do with that one. Okay? Ansley and then Cynthia. Yeah.
Oh, yes.
Okay, so number 1 is a logistics problem. We have our limit to growth on this one. So this is 50. This is the maximum growth, right? So that's where that upper asymptote goes at y equals 50. Then really all you have to do to graph this is plug in 0 for x. When you plug in 0 for x, you get 50 over 1 plus 24 e to the 0. Well, e to the 0 is 1. And 50 divided by 25 is 2, which tells me it crosses the y-axis here at the point. It's a little hard to read that. I'll make it bigger. Wait, I tried to white it out. That didn't work. 0, 2. So it crosses the y-axis here at the point 0, 2. And then just make a curve. Now, last period somebody asked me about the domain and the range. Now, generally, these logistics problems are in terms of word problems. And so the domain wouldn't go on forever. It would usually start at 0. And the range wouldn't start at 0. It would start at the y-intercept times 0. But this one we weren't given context for a problem. We were just given the function. So we would include the entire domain and range. Now, I put the extra characteristics on here. You didn't have to do that. I changed your directions before I printed them out because really all we talked about in class was domain, range, and roots. And because that's all we talked about in class, I changed your directions here. So you only had to do domain, range, and roots. Now, somebody asked me about this one. This one crossed perfectly right here. But if it didn't, how would we solve it? We would set it equal to 0 and solve. That would give us the root. So it would become 3 to the 0 equals x minus 4 when we switch forms. 3 to the 0 is 1. We would add 4 to both sides and we would get x equals 5. Is that the same thing we got when we looked at the graph? Yes, it is. Yes, ma'am.
Tomorrow will just be domain, range, and
Roots. Yep. Yes, ma'am.
So if it's log or ln, the asymptote goes this way, but if it's e or not e, it goes this direction?
Okay, so if it is a logarithmic function, it does have a vertical asymptote. If it is an exponential function, it has a horizontal asymptote. Yes.
Okay, thank you.
Sophia, what was your question? Like I called on you and then I ignored you. Number 14?
no 13.
13. Okay, let's go check out 13.
That's a great question. I mean, the answer
Like some of the questions I was able to look on the answer key and figure out what
Okay, so this says to rewrite as a sum, difference, or multiple of a logarithm. So we're going to completely expand this logarithm. Now when we do this, multiplication becomes addition. The division becomes subtraction. And the exponents come out in front and become multiplication. So, there's one more thing that we can do with this though, because log base 3 of 3 is 1. So we actually could take this a step further and write it as minus 1. That didn't look like a 1.
So
Try
on
again.
the
There we go.
test, will Sarah, do you write the expression as a sum, or will it say expand?
It'll say either that or that. I'm not sure which words I would use. Jack, then Zenny.
Can you do number 7?
Okay, number 7. This could be rewritten as 1 over e to the 3 halves
3. Also the square.
because it's the square root of, and remember with our rational exponent, the top number is the power, the bottom number is the root. So the square root of e cubed could also be written as e to the 3 halves. Now, because it's in the denominator, we could also think of this as e to the negative 3 halves. And when I do that, the negative 3 halves could come out in front. And what is the natural log of e? 1. So the answer is just negative 3 halves, or negative 1.5. Okay, Zimmy was next.
Can you do number 16?
Number 16. Alright, so on this one, what we would do first is move the 7 over. And so we get negative 2 equals negative 2 times the square root of x to the 5th. Then we divide by negative 2. 1 equals the square root of x to the 5th. Now because it's 1, the only answer is 1. But if this was any other number than 1, what would you have to do to algebraically solve this? We would think of this as x to the 5 halves. And then we would raise each side to the 2/5. But 1 to any power is still 1. If it was any other number than 1, it could change here. Okay, Madeline?
15 and 18.
Okay, 15. All right, negative exponents go down. They move. So I'm going to start by simplifying the inside. 4 and 6 reduce. So the 4 turns into a 2. The y stays put. The 6 reduces to 3. I moved 2 of these down. I already had 1, so now I have 3 x's in the denominator. You with me?
Why not?
Yeah, I don't
3
get that.
for the x to the 3rd.
Because this x was to a negative power,
No, I get the
so
x.
it has to move. We had 1 x that was already down there. 2 more joined it. So now we have 3.
I get the 3 before that.
Okay, 2 goes into 4 2 times. 2 goes into 6 3 times.
Write it.
Okay? So that gets us there. And now this flips it. So now we have 3x cubed over 2y to the 5th squared. And then we just square everything. 3 squared, 9. This squared this. 2 squared, 4. This squared this.
Oh boy.
Jack?
18.
Yes.
18. And all right, so x is raised to the 3/5 power. So we would raise it to the reciprocal. So 5/3, 5/3. So 8 to the 5/3 power. That means the cubed root of 8 to the 5th. Well, the cubed root of 8 is 2. And 2 to the 5th is 32. Yes, ma'am. Number 4. Okay. All right. So this is a good question. What we look for when we're trying to figure out what this base is, we look at our asymptote and we go, all right, we're looking for the point that's 1 unit away from that, because that tells me where my function shifted to. So right here, it's 1 unit away from the asymptote. So all it did was shift to the right 1. Now, how do I figure out the base? This is how I figure out the base. If I go up 1, I go over 1, 2, 3. So what base do I raise to the first power and I get out 3? 3. Does that make sense? Yes, ma'am.
Number 3.
Alright, so on this one, this shifts your asymptote down 1 unit. So this shifts it right 2 units. Hold on, I'm missing a tick mark right here. There we go. So this is our starting point right here. Right here. Down 1, right 2. So if I go over 1, left 1, it's like 1 over 2.7, about up a third. E to the 0 is 1. And then e to the first is 2.7. And then sketch your graph.
Okay, so like, and then when you have it horizontal, like on your x and y table, you would do like the x's as -1, 0, and 1.
Right. When it's an exponential, -1, 0, 1 go here.
Okay.
So this is x and y is e to the x. So it's like 1 over 2.7, 1, 2.7. Ansley?
Can we do 25?
Sure. Alright, so if we are to solve this, we have to condense this side first. So these have to go back. So it becomes log base 7 of 2 cubed. Addition changes to multiplication, 27 to the 1/3. So 2 cubed is 8, and the cubed root of 27 is 3. So this becomes log base 7 of 8 times 3, and 8 times 3 is 24. So now we have logs on both sides, and we square both sides. And 24 squared is 576, right?
Yes.
You're welcome. Jack? Which one?
22 and 23. You want something extra?
Okay. For 22, we're going to just take the log or natural log of both sides. There's nothing extra on that problem, so I can go ahead and take the log or natural log of both sides. Alright, the x minus 5 comes out in front, and we have to divide by ln of 14. We add 5 and we're done. So it's the natural log of 625 over the natural log of 14 plus 5. Okay. 23, the first step is to divide by the 4. And then we would take the natural log of both sides, and we would definitely choose natural log because this is base e. So when we do here, take the natural log of both sides, the natural log of e is just 1. And so this comes out in front times 1, which doesn't matter. So your answer on tomorrow's part of the test would be that.
The exact one.
Yep, the exact one, because tomorrow is your no calculator day.
Oh, it is?
Yeah, part 1 is no calculator. Part 2 has all the word problems on it.
That's how we do number 25.
I'll probably give you a smaller number, like 14 squared, one that you should know.
Should I be writing that down?
That's,
Yeah, can I write that out?
196.
196.
Okay.
Yeah, that's right.
Alright, which one?
So that's right.
Alright,
Will sequences be on the?
no. It will not be tomorrow, it'll be Friday, because you need a calculator for sequences and series.
Oh my gosh, so it's
Yeah.
on tomorrow.
Yeah, sequences and series, the only word problems we might have would be like a bouncing ball kind of problem. But you do need the calculator for those, so they'll be Friday. You said 20?
yes.
Okay.
126.
So this is gonna come back and become the exponent. And then we have a log equal to a log. So you set the answer parts equal. You can kind of drop the log because you have a log equal to a log. So you set the answer parts equal. And then because this is to the 1/2, I would square both sides. Because 1/2 power is like square root, so you'd square both sides.
Time?
And then move the 3 over.
I thought you.
Yes, ma'am. Alright, so we have to condense this side. The addition changes to multiplication. So we have to multiply x minus 2 times the 3, which is where the 3x minus 6 came from. So once you have a log on both sides, you just set the answer parts equal to each other and solve.
Oh, questions, okay.
Yeah, questions? Any more questions on this, or are you ready to go back to circle problems?
Circle problems.
Okay, let's go circle.
Yeah, we got this. God bless you.
Somebody asked me about ones like 53.
Yes.
Okay, so 53 was an ugly quadratic formula. I would not give you one where C was 10,002 to do without a calculator.
What was that?
So, yeah.
That's what we, hold on.
See, I'm not gonna be able to find my work though.
It's number 55.
It really is.
A neat way to be able to cure that is to write the problem number out beside your number.
I